So today I'm just picking up with that last problem from 7.6, and then I made a compilation of questions that were most commonly missed from the last two quizzes. I haven't had a chance yet to grade your quiz that was due yesterday? I believe. Yes, it was due yesterday. But I should get that done today. So you'll have that stuff with reviewing for the test. As I said, on Monday, I did get that test review posted. So that's in Eagle Online. So you'll find the test review in there. It also has the solutions so you can go through those. Before I get started, any questions for me? Okay. So like I said, our last example that we're going through has to do with manufacturers and supplying items. And this is again an example of Bayes' theorem where we know the outcome, but we want to know what is the probability of the beginning event. So it says a manufacturer buys items from 6 different suppliers. The fraction of the total number of items obtained from each supplier, along with the probability that an item purchased from that supplier is defective, are shown in the table. Find the probability that a defective item came from supplier 5. So first we need to define our variables. So I'm going to let F be the supplier. Oops. Helps if I spell it right. And that means that I'm going to let supplier 1 be F1. F2 be supplier 2. F3 be supplier 3. F4 be supplier 4. F5 be supplier 5. And F6 be supplier 6. So if we think about just drawing the first part of our tree diagram based upon that, these lines a little closer together, it's a little too crazy. So I have F1, F2, F3, F4, F5, and F6. So those are my suppliers. Again, this first column here where it says the fraction of total supplied, that's saying of each supplier. So for each supplier, what is the amount that they were given or that they supplied? So for supplier 1, it's 5%. So the probability that it's coming from supplier 1 is 0.05. So I can add in these probabilities here. So now we've got the probability that's defective. So we're going to let E equal defective. So item is defective. And to give ourselves a little bit more room, I'm going to pull our thing down just a scotch, give us a little bit more room. So hold on one second. Okay. So for supplier number 1, it has a defective rate of 0.04. So we've got the outcome that it's defective, which is 0.04, or the outcome that it's not defective, which is the complement of this, which is 0.96. Supplier 2, it has a defective rate of 0.02. So again, we have event E that's defective, 0.02, versus the complement, 0.98. For supplier 3, we have a defective rate of 0.07 versus a non-defective rate of 0.93. And again, how am I finding those? I'm just taking one minus the probability of defective. They're complements of each other, so they have to add, the two events have to add to be 1. For supplier number 4, we have a defective rate of 0.01. Therefore, the complement of that is 0.99. For supplier 5, we have a defective rate of 0.03 and a non-defective rate of 0.97. And then supplier 6, we have a defective rate of 0.05, which means we have a non-defective rate of 0.95, not 0.05, 0.95. So it says find the probability that a defective item came from supplier 5. So in order to identify that it's defective, so we're looking at the probability that it came from supplier 5, given that it's defective. Move this smaller now that we've filled in. Nope, it's going to be that size. Okay. So remember, we think about what do we want to have happen? That's the numerator. That's the intersection of defective and it coming from supplier 5, which is this branch right here. So if we look at that probability, it's going to be 0.35 times 0.03. So that's my numerator. And remember with this, it then is always to be defective. Okay, so the denominator is all defective. So all defective is going to be all the green branches. So it's going to be the sum of those 6 probabilities at the bottom. So again, we need to first multiply them together. If I can write this all out. It looks like I'm running out of room. Let me go to the next page with this. It won't let me copy it. So I'm just going to go to the next page. So we're just rewriting here. Oh my goodness, I'm running out of room. I just need to write smaller and I'm not doing well at that this morning. I'm just going to add this little extra bit on here. I apologize. So Again, to calculate this, we need to find the product of the numerator and then the sum of the denominator products. And again, how do I know this is where this needs to, how do I know that that's what I need to do? So if you remember the, it's going to be, because again, we're looking at, this is the probability of item coming from F1, given that it's defective. And then the second one is F2, F3, F4, F5, F6. It's all the defective from all the different manufacturers. So in order to find the probability that the defective item came from supplier 5, given that it was defective, is what we want on top, supplier 5, and defective out of all possible defectives. So when we multiply this together, we end up with 0.0105 as my numerator and 0.0329 as my denominator, which reduces to a probability of 0.319. So we have a 31.9% chance that if an item was defective, came from supplier 5. And the reason why that probability is so high is I want you to see the fact that supplier 5 is already supplying the most of these items, right? The most of that is coming from supplier 5. So you're going to have a higher probability that that defective item is coming from them. So Bayes' theorem, it's a complicated concept, right? I want you to know you will be tested there's only going to be one problem on your exam over Bayes' theorem as compared to everything else in it. So I don't want you to think like, oh God, if I don't get this, I'm not going to do well in the exam. The exam is made up of multiple parts. It's going over all of chapter 7. So this one little bit is a small part in the bigger thing. So like I said, I also wanted to go over questions from the quiz that were most commonly missed. So I compiled a list of those. I didn't get a chance to upload it to Eagle Online so you could have them to write down. But I have it here for us to look at. So give me 1 second while I pull this in. So this first question says, let A be, and then it gives us the set and determine if the statement is true or false. And it says the set 6 is an element of A. So this is false for 2 reasons. And why is it false? Well, for the first reason, if we look at this set notation, we have brackets within brackets. That's not even proper set notation. So first of all, this is not proper set notation. If we were to write it out properly, it would be let A equal, and we'd have one set of brackets. And the next part is that the notation here. First of all, what this is saying is that the set containing the number 6 is an element of A. So, and really this is a subset. So subsets can't be elements, okay? So the fact that it has the curly brackets is changing the definition. In order to be true, so which is not possible, because subsets can't be elements. Okay, so in order to be true, we have to write it as this way. 6 is an element of A. So you can see that it does not have the brackets around the 6, which now means that we're just listing it as it is, not as a subset or anything like that. So the next one says shade the Venn diagram to represent the set. So I want you to try this one on your own. Obviously, you can't send me a message with your answer. I just want you to try solving this. So you've got B union with, and then parentheses, A intersecting C complement. So I want you to try this, record your answer. I'll give you a few minutes and then I'll do it too, and we can compare our results. Okay, so remember with doing these, we want to focus on what's inside the parentheses first. So I'm going to draw a series of Venn diagrams. So I've got the first one, which is going to represent A intersecting C complement. So we think about C complement, it's everything that's not C. So if I shade everything that's not C, it looks like that, right? So with intersects, remember we want to think of it being two colors. We're looking for where the overlap happens. So if we shade A in blue, we're looking for where does the intersect happen? And that intersect happens right here. The blue overlaps the green in these two regions. So that is all I want to take from this drawing, okay? Because we're now going to take that answer and we're going to union it with B. So now from here, we're going to draw a new drawing. And we've got B union A intersect C complement. So A, B, C. I'm going to shade that answer from the first one first. So that looks like this. Now remember with unions, one color. So you just keep shading it. So if we're going to union it with B, that means we're just going to keep going and color the rest of B in. So then our solution set is everything green that's on the right. So again, if you're thinking intersect two colors, look for the overlap. In union, one color, and all I can say is just keep going, right? Like you color the first bit and now you're unioning it with the next bit. So you just keep going and coloring the remaining portion. So questions about that one. There will be a question on your exam that will have you shade a region. So my suggestion to you is to do like I did here, where I started with one drawing, drew an arrow to give me my final drawing, right? And so you're going to want to end up showing the final drawing. It's indicating to me somehow on your exam that this is my final answer that represents something. Okay, so the next one says use a Venn diagram in the given information to determine the number of elements in an indicated region. So please let me know if you can't read this. So it's telling us the number of elements in the universal set. So if we think about the universal set, that's all the regions together plus the outside. Number of elements in A, B, the intersect of A and B, the intersect of A and C, the intersect of all three, the intersect of none of them, and of A complement intersecting B intersecting C complement. So I want you to try your hand at this. Okay, so I'm going to give you a few minutes to work on that. And I want you to see if you can come up with an answer for C. I want to find the total number of elements in C. Trying to make it a little bit bigger for you.
Okay, so let's look at this. First of all, we're going to have three regions, or three circles, excuse me. Actually, let me draw it a little bit bigger. So this idea that the number of items in the universal refers to the whole thing has to add to 180. So every single region with those circles overlap and the areas themselves, plus that outside, all of it has to add to 180. So remember, when working through these, always try to work with the most restrictive areas first. So we can see right here, the number of items in not A intersecting with not B intersecting not C, that represents this region out here. That's outside A, B, and C all together. So that's outside of that. Also, we can see in the list right here that A intersects B intersects C. That's this little tiny region in the middle, and that's where the 13 is. So from here, we can start moving out. We know that the number of items in A intersects C is 28. A intersects C in two regions. So if I've used 13 of them already, I'm going to do 28 minus 13, which gives me 15 in that region there. We can see that A intersects B for 25. So again, we've already used the 13. So we're going to do 25 minus 13, which gives us 12. The number of items in A is 60. The reason I went to that is because the circle A has four regions that make it up. It's the section that's A itself, the section where A and B overlap, the section where A, B, and C overlap, and the section where A and C overlap.
So I'm going to use this 60 and subtract off the 12, 13, and 15. And 60 minus 12 minus 13 minus 15 gives me 20. So now what can we do? We've used a lot of these. What can we go to next? Well, the piece we can go to next is this piece right here. So if you want to make a little diagram on the side. So I'm looking for A, B, and C. So B, I'm going to shade in blue. Okay. Not A, I'm going to shade in green. And not C, I'm going to shade in purple. So what is the one area where all of the colors overlap? Because that's what we're looking for, the intersection. And that area is right here. This little half moon here. Or not even a half moon, it's just this little bit. This is the area where all of those colors overlap. So that means if we go back to our drawing, that this is 42. That's where those 42 live. So from there, we can use the number of items that are in B, which is 80. So we're going to do 80 minus 13 minus 12 minus 42. Which gives us 13 in this region. And then in order to solve for the very last region, we have to use the fact that it's 180 for everything. So we're going to take that 180 and minus all the numbers we have in here. So minus 20, minus 12, minus 42, minus 15, minus 13, minus 13, and minus 45. Which gives us 20 remaining. So just filling out the Venn diagram isn't enough to answer it. The answer is find the number in C. So when we think of C, we're thinking of the entire circle of C. So all of that is C. Therefore, to add up for the number of items in C, we have to add those 4 regions. So we have 15 plus 13 plus 13 plus 20. Giving us the number of items in C is 61. So the key piece that we had to figure out was this little extra Venn diagram there, right? We had to identify what did that piece mean when it was telling us that not A intersected B and intersected not C. We needed that in order to continue with everything else. So questions on that one before we move forward? Excuse me. So the last one I want to look at today is this genetics experiment on pea plants. I think this problem was on your homework. It was also on your quiz. And this is the one, unfortunately, that when I did the lecture, I wasn't able to get to. So it says after a genetics experiment on 55 pea plants, the number of plants having certain characteristics was tallied. With the results given to the right, answer parts A through C. So we're looking at tall, green, and smooth peas. And this idea of 55 plants represents the entire thing. So again, always start with the most restrictive regions. So if I look at my list, I've got 19 were tall, 30 had green, 33 were smooth, 6 were tall and green, 18 were green and smooth, blah, blah, blah. And then I get to the 2 values where it says 4 had none of these characteristics. So we will put those outside, and that 3 had all of these characteristics. So those are those 2 regions that we always want to zero in on first in order to build out from there. So now we have the statement that 18 were green and smooth. So 18 being green and smooth is the 2 regions where green and smooth overlap. Again, we've already used 3 of those. So we're going to do 18 minus 3, which gives us 15. 6 were tall and had green peas. So tall and green, again, it's overlapping in 2 regions. We used 3 of them already, so we'll subtract 3 off. And then from there, we have to decide, do we want to go with the characteristics that all of them are tall, green, or smooth? Well, with the green circle, we already have 3 of those 4 regions colored in. So we're going to come up with the rest of this, which is 30 minus the spaces we've already used. So 30 minus 3 minus 3 minus 15 gives us 9. Unfortunately, now it just tells us the total that were tall and the total that were green. Okay. So because it doesn't give us any more information about anything overlapping, we have to declare a space a variable. Okay. So I'm going to declare the overlap there, the variable, because the number that were tall and the number that were smooth both depend on that region because it's where those 2 circles overlap. So using the idea that 19 were tall, we can take 19 minus 3 minus 3 minus x, which reduces to 13 minus x, and that's going to represent that region. For the smooth, oops, I marked off the wrong thing. 33 were smooth. So again, we can do 33 minus x minus 3 minus 15. When we reduce that, we get 15 minus x. So from here, we have all of our regions represented. And therefore, we need to use this idea that they all add up to 55. So I want you to go ahead and find the value of x and finish filling in those spaces that depend on x. So remember, it all has to add to be 55. So use that concept to find what x needs to equal. So adding all those regions up, we get that x equals 7. So if we go back to our drawing and get rid of our x's, we have 7 in that intersect extra bit. 13 minus 7 is going to give us 6. And 15 minus 7 will give us 8. So if we look at answering these questions, it says find the number of plants that were tall and had smooth peas. So tall and smooth is going to be 2 spaces. What are the 2 places that those 2 overlap? Well, they overlap in both the 7 and the 3. Therefore, we need to add those numbers together. We're going to do 7 plus 3, which gives us 10 for tall and smooth. The next question says, how many plants were tall and had peas that were neither smooth nor green? So it's just tall. They can't be smooth or green, which means we're talking about this region right here, because those are the only ones that are only tall. It's excluding the greens, excluding the smooths. Therefore, we have 6 that were just tall. And then C says smooth and green, but not tall. Smooth and green, but not tall is this very specific area. We need smooth and green to overlap, but it can't include the talls. So it's just going to be those 15 there. So the biggest piece of this is that you have to, because we didn't have all the information, we had to represent a region with a variable and then move out from there using the fact that all the regions had to add to 55, meaning that all the plants we were talking about, there was a 55 total. So that is the our time limit for today. On Friday, I've got 1, 2, 3, 4 more problems I'm going to go through just to continue to review. I should have your quizzes graded by then. I will upload this worksheet into Eagle Online. So if you want to print it out, I'm sorry I didn't get a chance to do it before our lecture today because I was prepping right up till the end. So that then you'll have a copy of it. And then also let me know if you want more practice problems in regards to Bayes' theorem. I do have some extra worksheets and stuff, so just email me if you want those. And I will have the test prepped to release after lecture on Friday, and then it'll be due next week on Wednesday. So you'll have the weekend plus a few days to work on it. Any questions for me before I let you go? So is there homework due today? There is. There should be 7.6 due. Let me make sure we've got that in there. Let me pull up. Sorry, Pearson logged me out. I just want to make sure that the date is in there. So my schedule shows 7.6 being due today. So yeah, 10/20. So it's due today. Does anybody need an extra day? I'm fine with pushing it to being due tomorrow. It's no big deal. Just if you want to put in the links in the messaging there, if you need it due tomorrow instead, I can push it out a day. Okay, well, we'll just keep it with it being due today. Like I said, I will get your quizzes graded before we meet together on Friday, and we'll just continue reviewing for the exam. All right, everyone, email me if you have questions. I hope you all have a good day, and I will talk to you later. Bye.